Hello guys, welcome back to Tronic Synergy, where we do fun stuff all day, all time. And today we have done a light intensity meter, or what you can call a luminous intensity meter. It means that it records how much light is there in a specific direction or in a place, and for that you need a light sensor. I'm using an LDR, which is a light dependent resistor. Right there you can see it in that end. Then the other circuitry are just to empower it, or to show how you can give a good output on this other side. These are just various ways. You can just use a single LED. I've done very many I've done some quite videos about light sensor, different adjustable light sensor and a light sensor as it is, but today we are improving our circuit more. So this will show you the intensity of light using these 4 LEDs right here. You can see this, the first one is a red LED, then yellow LED, and this is a yellow LED, only that it is turned off because the light has not yet reached that amount. So if I try to block light at this sensor, you will start seeing the LEDs being turned off slowly from my right to left. So I'll start blocking. You can see the second LED is off. Then if I do it even further, if I try to block light in that sensor even further, you can see that is already blocked. Then if I try, then this is quite hard to turn off the red one, because the red one needs a totally dark place for it to be turned off. So you can try to block. Then if I release, then this LED starts to light up. Then the second one, then the third one needs a lot of not lot of light, but some quite amount of light more than this one in order to light up. So I can light up my camera light to show you. Then it is on, and once it is on, it turns on this circuit, which is right here. Sorry for that, this LED is not okay. So it turns on this circuit right here, which has an N55 oscillator mode, and the output is an LED, blue LED, and a buzzer right there to show you that the light is at its maximum. The meter is at its maximum value. So if I turn off my camera light, it turns back to normal. So if I block it, then the LED starts to go off one by one until when it's purely dark, then this the last LED will be turned off. So that's basically what we are going to do today. Please enjoy the show. Welcome back to Tronic Synergy, and today we are doing this circuit. Is a light intensity meter, or a luminous intensity meter. So it's a meter that measures the amount of light in a place or in a specific direction according to how you have built your circuit. So for mine, it's going to be detecting light all over around the sensor, which is right here. This is an LDR, which is a light dependent resistor that works in the principle that when there is light, then it reduces its resistance, and when there is no light, it increases the resistance of that device. So right there, we place it right there, and it enters this BC547, which is an NPN transistor. That so according to how much the current enters here, it's going to allow different voltages to go to different comparators, which have different V references, and they are going to turn on their different LEDs according to how much voltage is fed into them. So this one is just, the transistor here is just to amplify that signal of that LDR in order to tap it into various comparators right there. So all these comparators are in one integrated circuit called the LM358, which is a dual comparator, and it has two comparators. So rather two of them are in one LM358 and the other two are in another LM358, because it contains only two comparators in one integrated circuit. I don't know if there are integrated circuits out there which have more than two comparators. Maybe I'll try to research and find out. So these comparators are in the LM358, and they have their different V references, which I'm using 10K potentiometers. You can use maybe 20K, but not more than that. But it all depends in your power supply. If you're using a bigger power supply, then you can use above 20K potentiometers. But if you're using for like mine, I'm using like 5 volts, so 10K potentiometer is quite the best option which you can use. And so from there we have these inverters right here. We have these inverters right here. All of these are in one integrated circuit called the TC74 HCU4P, which is a hex inverter, meaning that it contains 6 inverters inside of it. So the outputs are going to enter into the inverters, then go to power the LEDs right here, which are arranged according to how much light is produced, detected by this LDR. So these inverters are not quite important. The reason as why I'm using them is just to amplify my signal, because I'm using a low power. If maybe you have more than 5 volt, like 9 volt, 12 volt, you don't need to use the inverters. You can just tap the power directly to your LEDs from the comparator's output. You can do it directly into your LEDs. And my LEDs down here have various resistors. They're just the same resistances. I'm using a 1 kilo ohm resistor. Also, this value depends on the power supply. If you're using a bigger power supply, then it means that you need a quite large resistance to protect your LED from blowing out, and then you connect them to ground right there. So it's a pretty simple circuit. You can do this at home at your breadboard, or you can just solder the circuit, and you are good to go according to what you want to build, or what you want to create. You can use this circuit in your various projects. So I'll show you my circuit is right here. So my circuit is right here. It's pretty much exactly the same as the schematic that I've drawn here, only that my output I've added some sort of another circuit right here, just for the convenience purposes. And so the others are basically the same. These are the two comparators. These are the two LM358 right there. You can see them. This first one, this is the second one. Then this silver these silver things here are the potentiometers, the V references right there. Then the TC74 hex inverter is right here. This is the hex inverter. So for this LM358, you need to check the data sheet in order to get the various maximum and minimum values to avoid blowing or destroying your integrated circuits. Then the TC74 hex inverter is right here, which is powering these LEDs. You can see powering these LEDs, and the resistances which are protecting the LEDs are right here. They are 1 kilo ohm resistances. The LEDs are arranged in that this is the first one, so this is the red one, the orange one, orange. So my light intensity starts from here and ends in here. So this means that there's low light. So this detects even the small light. Maybe in a dark place this will be off because there's minimal light. So in a dark place this should be off. So then it starts building up until this point, which is the highest light that can be recorded by this sensor. So you can use even more LEDs. That depends on how many comparators that you have. If I add another comparator integrated circuit, then I can add like 2 more LEDs right there. So because I'm using only 4 comparators, I need only 4 LEDs as the output. So if my last LED lights on, then I've also added this circuit to show that the maximum value has been reached by the meter. So this is simply an NE555 in the stable mode, and the output right there has a blue LED and also has this buzzer. This is the buzzer. So you also need to protect them. The buzzer has a 330 ohm resistor. The LED has a 1 kilo ohm resistor, and the 330 ohm resistor for the buzzer is just to minimize the sound. You can minimize the sound by how much resistance you use on it. Then because it's an oscillator mode, it means that it oscillates. So you need to put a capacitor right there according to how much frequency you want the oscillator to run. So typically you can just use 100 microfarad. It's not too fast, it's not too slow, and then it's not going to produce a lot of noise, the buzzer. So 100 microfarad is just the best option to use, or you can use a 22 microfarad if you want it to be turned on faster and faster, or to increase the frequency. So, and my power supply is 5 volt as I said, and the LDR yeah, is connected to this transistor which is there. This is the BC547, which has a resistor from power supply. I'm using a 2.2k, and then it's grounded on the other side. So that's my circuit, and I'm going to power it on to show you what it does. So immediately you see all of them are on because my camera light is on. So the LDR will detect every single intensity has been reached by the meter according to how I've set the V references. So I'll turn my camera light off to show you how. So I've turned it off, and immediately the last LED is off, meaning that it has turned off even the circuit that shows you that maximum intensity has been reached. So my maximum intensity right now is on the third LED, and so if I start blocking light from the sensor, then the LEDs will start one by one going off, meaning that there's no light at the sensor. So I'll block them using my hand to show you. So I've already started blocking, and the second LED, the third LED is off. So I'll continue further. Then this LED is off. Then this is the last LED. So this is quite very hard to block the red LED because I've set it to be really sensitive at only dark places. So only if there's pure darkness on this side, or if it's at night, maybe then it will be turned off. So it's very hard to control it. So once I start to lift my hands, then this LED should be the first one. Yes. Then if I continue, this should be the other one. Then I'll leave it. Then the light is not still enough to light on the last LED, which shows you that maximum light has been reached. So to light it, I'll add my camera light in order to, yes. So if I add my camera light, then it detects maximum light has been reached around the sensor, and then it turns on the circuit to show you that maximum light has been reached. So that's pretty much the circuit. Yes, so you can just do this at home. This is pretty simple, and hope you enjoy making this. Pretty simple. You can slow the video and check the interconnections and try to understand the schematic. It's pretty simple. You just need to be you just need to compose yourself and make sure that you connect everything in the right way, and to check the maximum ratings of this integrated circuit. So yes, so that's what I wanted to show you today, and thank you very much for watching. Please subscribe to Tronics Energy, where we do fun projects all day, all time. So share this video to as many people as possible for them to learn how to do these projects at home as well, in their various school projects and in their personal projects. So thank you very much, guys, for watching. Hope to see you next time. Goodbye.